Okay, so we are down to the last two methods we're going to learn as far as ways to calculate the number of options available to us in a particular problem. In the second to the last option we have is something called a permutation. The last option is something called a combination. And just like the names are very similar, the way that we use them and when we use them, all of those sorts of things are very closely related. So you'll see a lot of overlap with this video and our next video. In this one, we're talking about permutations. In the next video, we'll talk about combinations. And then that will end our discussion on different ways for calculating the number of options that we have available in a certain problem. All right, so with that said, let's get started with our discussion on permutations. Learning objectives here. First one is just to be able to calculate the value of a permutation. For our class, I'm just simply going to show you how to do that on a calculator. There is a formula for that. And if you do a little research on the internet, or if you can find a math book or what have you, you can find that formula. It's not a particularly hard formula to use. But for our class, and considering that we're running short on time for the school year, I'm just going to show you how to do that in the calculator. And then the other thing that we'll need to know is when to use them. Between these two, then we'll be able to use permutations to solve problems. Okay, so let's start with the first thing, knowing how to calculate it. And hand in hand with that is knowing what it looks like. Okay, so permutations on a calculator. Okay, permutations on a calculator. First of all, what it looks like. Okay, permutations are going to have two numbers with a p in between them. So maybe I'll have something like 10p3. I'm just making up some numbers there. 10p3. We'll talk about what that means in just a second, but this is what it's going to look like. Now, the way you get this on your calculator is you start by typing in 10, okay, which makes sense because the 10 comes first. But then the next thing that you're going to do is go to the same menu where you found the factorial feature from our previous video. So on this particular calculator that I've been showing you, I can just hit alpha window. That opens up a menu. Option number 9 was factorial, but notice option number 7 here is something that is a blank p blank. Now they write it with variables n, npr, but whatever. If you look at the form over here, it's blank p blank. And so those two blanks are where my numbers will go. So if I type in 10, and then I go to alpha window to open up this menu, and I choose option number 7, that puts the 10 into a space down below my p, just like I've got here. And it gives me another space here where I can type in the number 3. So now I've got 10p3 on my calculator, just like I have on my paper. And if I hit enter, it gives me the answer. So 10p3, or 10 permute 3, I might say, is equal to 720. Okay, so that's what it looks like when you do it on your calculator. But of course, then the question becomes, what does that mean? What does that mean? Okay, so let's talk about the meaning of this. And the meaning of this will help us then transition into how do you know when to use it, right? So first of all, this means I have a group that has 10 things in it. That's what that number means. I have 10 things in a group. And this number over here means I'm going to pick 3 things from that group and arrange them in a specific order. Three things will be picked out of the group and arranged in a specific order. And so what 720 tells me is this tells me how many ways I can arrange how many ways I can arrange 3 items from a group of 10 items. Okay, so let's think about what this might mean like in real life. Imagine, if you will, a race that has 10 runners in it. Okay, now typically in a track race, you probably only have 8 or 9 runners, at least in the sprints. Maybe if it's a longer race, maybe this is, something like the 800-meter race or something like that. But maybe I've got a few more runners. This race has 10 runners in it. So there's 10 runners in my race, 10 things in my group, 10 runners in my race. Okay. The top 3 finishers are going to get a medal. Okay, so maybe gold, silver, and bronze medals. My top 3 finishers are going to get a medal. And so 720 represents the total number of different ways that the 10 runners could run the race and find 3 of them getting a medal. Okay, so if this was like, for example, if this was the Olympics, let's say that the 10 runners are all from different countries. So I've got a runner from the US and a runner from Canada and a runner from Russia and a runner from Georgia, a runner from Germany, a runner from Japan, whatever. Okay, so I've got 10 runners total. All right, so maybe one time I have a race where the US runner gets the gold and the Canadian gets the silver and the French runner gets the bronze. Okay, so that would be one outcome. A different outcome would be if those same 3 people finish, but in a different order. Maybe the Canadian gets the gold and the US runner gets the silver and the French runner gets the bronze. That would be a different outcome. Or maybe the runner from Russia gets the gold and the second place runner is from Japan and the third place runner is from Georgia, whatever. All of those would be different outcomes. And that's what this 720 represents, is the total number of different ways that 3 runners could get the medals in a race that has 10 runners in it. Okay, so that's the idea of a permutation. And that's what it means. So you can see that permutations deal a lot with selecting things from a group and then arranging them in an order. Now, I will say that's the easiest way to understand a permutation, but you'll see when you get into some of the homework problems and stuff that that concept can spill over into other ideas. We don't necessarily have to be arranging runners in a race. There's other things I can do. For example, if I have 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? 10 single-digit numbers. And I'm going to pick 3 of them to make a 3-digit number, okay? How many ways can I do that? Well, apparently there's 720 ways to do that. So maybe I pick these 3 numbers, or maybe I pick these 3 numbers, or maybe I pick these 3 numbers, or whatever. There's apparently 720 ways that I can do that, right? So this is the idea. Now, immediately, I can probably imagine you're sitting here thinking, wait a second. If there's only 720 ways, that doesn't make any sense, because just to go from 100 to 1,000, there's 999 or 1,000 numbers in between here, right? Because 100, 101, 102, 103, all the way up to 999, that doesn't seem right that there's only 720. So that brings us into when can we use permutations? And that'll explain why this number is smaller than the difference between, why isn't it 900, right? 1,000 minus 100, that should be 900 options, right? Why is it only 720? So let's talk about that. When can you use a permutation? When can you use a permutation? Okay, when can you use permutations? Well, there's basically 3 parts to this. 3 parts to this, okay? So the first part is that you have to have multiple things happening, multiple events. Multiple events, okay? So kind of like fundamental accounting principle, we have to have multiple events. In the example of my runners running a race, I've got 10 events total, right? Each runner running the race, as each person finishes, that's a different event that's happening, okay? So we have multiple events, that type of a thing. So that's just like fundamental accounting principle. But unlike fundamental accounting principle, I have an extra requirement: no replacements. No replacements. Now, what does that mean? That means once something has happened, it can't happen again. So for example, if I think of my runners running, if the American gets first place, he can't also get second place, okay? He only gets first or second, can't get both. That would be a situation with a replacement. That also explains why is it when I'm arranging numbers like this, there's only 720 and not more. The reason why is because a number like this is not allowed in this scenario because the 9 is happening twice. The 9 got replaced. I picked the 9 and I put 9 back in the pot and I picked it again. That's not allowed. So if I'm arranging 3 digits to create numbers using a permutation, these types of numbers are not allowed to have. Only numbers where nothing repeats are allowed. Okay, so there's no replacements. And then the third item gets into the heart of what permutations are really all about, is that the order is important to us. The order is important to us. All right, so when we're running a race, I guarantee if you talk to all the people running the race, whether they get the gold medal or the silver medal, that is important to them, okay? If we're talking about 3-digit numbers, if I said, look, you can have $123 or you can have $504, I guarantee you're picking this option, right? Because the order is important to us, the order that those digits are in. That matters to us, okay? So that's the 3 situations that we have to have in order to use a permutation. So with that said, let's take a look at an example, all right? On Monday, 5 of the 20 students in Mrs. Smith's class will present their essays. How many ways can we arrange the presenters for Monday's class, okay? So let's think about this. We've got 5 presenting in a class. There's 20 students altogether. From the 20 students, we're going to pick 5 to present the class. So right away, we can see there's multiple events. We're picking all these different students. We're picking 5 students to present. Okay, so there's multiple events happening. Okay, now I promise you that none of the students are going to want to present their essay more than once. And speaking as a teacher, I'm pretty sure Mrs. Smith doesn't want any of the students to repeat their essays either. So this is definitely a situation where there's no replacements. Once somebody presents their essay, then they don't have to present it again. And the other thing I know from my time as a student doing public speaking is that whether you're the first person to present or whether you're the last person to present makes a difference. Some people don't like to be the first person to present because it's like, let's let somebody else go first and sort of break the ice. Some people like to go first because they're like, I just want to get it over with, okay? But in either case, you have this emotional connection to whether you're first or second or third, and so the order matters. And so what we have is all 3 of these requirements are being satisfied. There's multiple events, there's no replacement, the order matters. So this is a permutation problem. The way I'm going to set this up is by finding the 2 numbers that are involved in the permutation. Well, there's 20 students and 5 of them are going to present. So those are my 2 numbers. In this particular problem, that makes it easy because those are the only 2 numbers. So obviously those are the ones I'm using. Now, 20 students, 5 of them are presenting. The way I set this up is the group that I'm choosing comes first. So there's 20 students total. I'm choosing from the group of 20. That comes first. And then I'll have the big P for permute, and then the number of students I'm arranging comes second. I'm going to arrange 5. So on my calculator, that's what I'm going to type in is 20 and then alpha window to get to my menu. Choose option number 7. 20 permute 5, and I end up with approximately 1,860,480. I guess not approximately, that's exactly what I got. Okay, so that's the number of ways that I could do that. That's a lot of options that Mrs. Smith has available to her there. A lot of options, right? So this is the idea of a permutation. I do want to finish with one small comment. As far as putting these 2 numbers into the problem, notice that if this is the group that I'm choosing from, and this is how many I'm choosing, you can never choose more than what's in the group. In other words, this number can never be bigger than that number. It could be equal, maybe I'm have a situation where the presentations are really short and all 20 kids are going to go. Okay, so I could have 20 permute 20, that could happen. But I could never have 20 kids and make 21 of them present an essay. That doesn't make sense. Not if there's no replacements. So the second number is always going to be smaller than the first number. And that will often help you set up your problem. Okay, so that's it for our discussion on permutations. Make sure you watch the video for combinations. But thanks for watching this and have a good one.